After learning to simplify rational expressions, multiplying and dividing rational expressions is actually pretty easy. We're going to take what you already know about multiplying and dividing fractions and just apply that to rational expressions. So let's take a look at multiplication. Multiplying rational numbers. Remember, a rational number is just an integer divided by another integer, or one number over another. It's just a fancy way of saying a fraction. So here's an example where we have 1/2 times 8 over 9. And if you remember how fraction multiplication works, we multiply the top times the top. So 1 times 8 is going to give us 8. And the bottom times the bottom, 2 times 9, is going to give us 18. Then we look and see if we have any common factors between 8 and 18. So I notice that both of them are even. I could divide both top and bottom by 2. So if I divide 8 by 2, I get 4. 18 by 2, I get 9. So this equivalent fraction would be 4 over 9 as my final answer. Now, it's totally legit to do the multiplication first and the simplification second. It's also possible to take the 1/2 and the 8/9 and simplify before you multiply. Now, we can always simplify each individual one, so if we had any common factors between 1 and 2, we could simplify those, and between 8 and 9, we could simplify those. But we can also cross-simplify and see if we have any common factors between 2 and 8 and 1 and 9. And we did, in fact, see that we have common factors between 2 and 8. We can divide them both by 2. So if I divide 2 by 2, I get 1. And if I divide 8 by 2, I get 4. And once I've run out of common factors, then I just do my multiplication. 1 times 4 is 4, and 1 times 9 is 9, and I get the same final answer. The only reason that this is kind of handy is because sometimes the division works out simpler to do it mental math in your head, or to even recognize that they have common factors before you end up with super gigantic numbers. But this rule, this cross-canceling, and this up and down canceling work exactly the same when we're multiplying rational expressions. So let's take a look. So I've got the rational expression 4x over 3x squared y times 9x y cubed over 2x. So if I wanted to, I can do the multiplication straight across. So 4 times 9 is 36. X times x is x squared. And I have a y cubed hanging along for the ride. And then 3 times 2 is 6. X squared times x is x cubed. And y comes along for the ride. And at this point, then, I can look at simplifying like you did in the last lesson. So 36 over 6 is just going to leave me with a 6 on top. X squared over x cubed is going to leave me with a 1x on the bottom, because there's more x's on the bottom than the top. And y cubed over y is going to leave me with a y squared on the top for my final answer. So I can do it like that, totally legit, no worries, but it's actually simpler, I think, if I look for things I can cancel top to bottom and cancel crosswise before I do all the multiplication. So thinking top to bottom first, I have an x here and an x squared there. So x over x squared can get rid of that x and get rid of the squared on the x on the bottom, leaving me with just an x. 4 over 3, nothing I can cancel, so that one would be done top to bottom. Then here I've got a 9 and a 2, nothing to cancel. X and x, those actually cancel straight out. So my final answer is only going to have this x right here as part of it. Then I start looking at the cross-canceling. So 4 and 2 have a common factor of 2, so divide 4 by 2 leaves me with just 2. 2 by 2 leaves me with just 1. And 9 and 3 also have a common factor of 3, so divide 3 by 3, I get 1. Divide 9 by 3, I get 3. And then cross-cancel the y and the y cubed, gets rid of this y, and turns the cubed into a squared. And then I see what I've got left. So I've got my 2 and my 3 and my y squared on top. So 2 times 3 is just 6. And y squared. And on the bottom, I have this blue x that I'd circled. So I get the same final answer. Now, one important thing to note is that I'm always canceling common factors. So when I start to have expressions that have addition and subtraction in them, I need to be able to factor them in order to figure out what my common factors are. So again, I'm canceling out factors, common factors of 2 and 8, common factors of x and x squared, and then that's what allows me to simplify. So let's take a look at the next example and see where that leads us. I've got x plus 5 over x squared plus 7x plus 12 and 3x plus 9 over x squared minus 25. So again, in order to be able to start canceling anything, I need to be able to factor everything. So x plus 5 already factored, can't do anything with that. If I can factor this bottom expression into my two parentheses, looks like it's going to be an x plus 3 and x plus 4. Taking a look at this top, I've got a GCF of 3, so pull that out and I'm left with x plus 3. And on the bottom, this looks like a difference of squares, x plus 5 and x minus 5. And now I start looking to see if I can pull out any common factors. So x plus 5 cancels x plus 5. X plus 3 cancels x plus 3. 3 doesn't cancel anything, and so what I'm left with on the top of my fraction is a 3. And on the bottom of my fraction, x plus 4 and x minus 5. So again, remember that even though these were in separate fractions to start with, we multiplied them, bottom times the bottom, and this just had turned into a 1. So 1 times 3 is 3. So this would be then my final answer. So again, you need to factor before you cancel. Always, 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 always factor before you cancel. I've seen some students who get really trigger happy and go, oh, n squared and n squared, those can cancel. No, they can't. Or 2 and 4, I can cancel those. You cannot cancel unless you've factored, unless they are a factor of the top and the bottom. So don't get too much ahead of yourself. You need to factor first. So n minus 3 doesn't factor. On the bottom, I've got a GCF of 2n, and then I've got a 2n plus 1. And then this guy here is going to factor into two parentheses. What do we got? 2n n minus 3 plus 1. I think that's going to get me my 5n when I multiply everything out. So this would be a minus 6n from those two terms plus 1n. That would give me my minus 5n. If you can't factor this as fast, you might need to do it over here in the margins. Try factoring by grouping or your Kung Fu method or whatever method it is that you prefer. Make sure you can factor. Then now that we're factored, we start to look for common factors to cancel. So I've got on the bottom 2n plus 1 and a 2n plus 1 on top. Now I do have an n minus 3 here and an n minus 3 here, but note that these are both on the top of my fractions. Remember that when I'm multiplying a whole number by a fraction, it automatically gets a denominator of 1. So you can imagine this expression here gets a denominator of 1 on the bottom. So the n minus 3's are actually both on top, so they can't cancel. And my 2n can multiply the 1 on the bottom to get my final answer. So I've got an n minus 3 times another n minus 3 is going to be an n minus 3 squared. And on the bottom, 2n times 1 just gives me 2n. And we're done with that one. So that is multiplication. Top times the top, bottom times the bottom. Cancel top to bottom and cancel diagonally. Now we're going to take a look at division. And again, if you remember how to divide fractions, dividing rational expressions is really not that bad. So I've got an expression like 1/3 divided by 4/6. And in order to actually do a division, we flip and multiply the second fraction called the divisor. So we take this second fraction and we flip it over, and that will turn us into a multiplication question. So this is the same as saying 1/3 times, flip this top to the bottom, 6 over 4. Let's see what we did. Flip it over, becomes multiplication instead of division, and then as soon as we turn it into a multiplication question, all the same rules apply that we've been dealing with since the beginning. I can cancel diagonally, so 3 and the 6 have a common factor of 3, so divide that by 3. Divide that by 3. Whoops, divide it by 3 gives me 1. Divide 6 by 3 gives me 2. And then I can also cancel top to bottom, 2 over 4. Can divide those both by 2. I'm just going to change colors. So divide 2 by 2 gives me 1. Divide 4 by 2 gives me 2. And my final answer then is going to be 1 times 1 is 1, and 1 times 2, 1/2. So again, to turn a division problem into a multiplication problem, just flip and multiply. And that's going to be true for pretty much all our rational expressions that we're going to deal with. So that's going to be the first step that we're going to use every single time, is flip and multiply. So I have 3x over 5x squared, and I want to make this a times. So I've got to flip the second fraction. Always the divisor, always the second fraction. So 3x over 5x squared times 15 over 6x. And then I can use all the rules I was using for multiplication. So looking top to bottom to simplify, I've got an x here, and the squared can go away. I have a 3 and a 6. I can divide those both by 3. 5 and 15, I can divide both by 5. Gives me 1, gives me 3. And on the top then, I think all I'm left with is a 3. And on the bottom, x times 2x is 2x squared for a final answer. All right, same thing is true once I've got rational expressions with some pluses and minuses. Again, flip and multiply, and if you can, you could factor at the same time. So here, I've got an m plus 5 over 2 minus m. I don't flip the first fraction, only the second fraction, only the fraction after the division sign. Multiplied by m squared minus 4. I'm going to factor that into m plus 2, m minus 2, and it's going to go on the top. And on the bottom, 3m plus 5. To flip the second fraction to turn us into multiplication. Now when I want to cancel things out, I've got an m plus 5 and an m plus 5. So I've got a 2 minus m and I've got an m minus 2. And these are very similar, but they're not exactly the same. And if I want to make them the same so that I can cancel, it's going to take some algebraic manipulation. So the first thing I'm going to do is rewrite this in the other order. I'm going to put the m first. So this would be an minus m. Remember that the negative needs to stick to the m, plus 2. So it looks similar again. Actually, it looks similar to both of these, but we're not quite there. In order to get this to look like the m minus 2, I'm going to pull out this negative that's in front of the m. So this would be like a negative, or I can even write this as a negative 1. And then m, pull out a negative 1. And then the plus 2, pull out a negative 1, becomes a minus 2. So now I've got negative 1, m minus 2. And if I multiplied this back in, convince yourself that you would get this expression back. So once I've done that, now I am able to cancel the m minus 2 and the m minus 2, and I'm left with this negative 1 is still on the bottom of this fraction. So it doesn't quite cancel 2 minus m and m minus 2. There's a factor of negative 1 that you've got to take out first. So once we've done that, on the top, I think the only thing that's left is an m plus 2. And on the bottom, I've got this negative 1. I've got the 3. I don't have any other expression. So that would be negative 3 on the bottom. And that would be everything you need for your final answer. All right, last one. Again, remember what we said at the end of the last question about multiplication is that when you have like something like 1/2 divided by 3, a whole number, the 3 automatically gets a denominator of 1. And that's going to be important to be able to flip and multiply. So I'm going to put that denominator of 1 underneath this whole big long expression, so that when I flip it over, the 1's going to end up on the top. So I've got y minus 4 over y plus 5. Flip to multiply. 1 ends up on the top, and I'm going to factor this bad boy to put it on the bottom. So this is going to be y plus 9 and y minus 4. Then cancel. In this case, cross cancel y minus 4 on the y minus 4. So this leaves me with a 1 here. And what I'm left with on the top is only 1. And on the bottom, y plus 5 and y plus 9. And that's it. Done, done, done. So that's fraction division, and then there's one more form of fraction division that we see, rational expression division, and that is called complex fractions, and it is fractions over fractions. So something like with our rational numbers, 1/3 over 4/6. This is a fraction over a fraction, and it is important that this is the long bar. This long bar is essentially putting invisible parentheses around the things above and below it. So I know it's 1/3 over 4/6. I'm not like, is it 1/3 over 4 over 6? Or is it 1/3 over 4 over 6? It's 1/3 over 4/6 because this fraction bar is longer. And what it essentially means is like the problem we saw in the previous one, 1/3 divided by 4/6. That's the long bar tells you where your division sign actually comes. So once we think of it like that, we can actually think of it again as a flip and multiply problem. So this is just equal to 1/3 times flip the bottom fraction. So flip the 4/6 to be 6/4. And then this is exactly the same problem that we saw up above. So we can cancel diagonally. This becomes a 1, this becomes a 2, and then cancel top to bottom. This becomes a 1, this becomes a 2, and we're left with 1/2. So just recognize this as another form of writing with a division sign, and you'll be fine. So again, same idea here. We're going to flip and multiply the bottom fraction because I'm thinking this is what's being divided. So this is x over 4 times flip the bottom fraction, flip the divisor. So this is 2x over 5 is going to be 5 over 2x. And then again, everything that we've worked on so far, cancel diagonally, x and x. 5 and 4 don't cancel, 5 and 2 don't cancel. These are both on the bottom, so they also don't cancel. So that means my answer is 5 over 8. Turns out all the x's cancel. Isn't that nice? Okay, again, same thing here. Just think the bottom is what's going to flip to make it multiply. So this is x plus 2 over 3 times 9 over, going to factor this to x plus 2, x minus 2, difference of squares. And then you can go ahead and cancel. So the x plus 2 cancels x plus 2. 3 cancels with the 3 from the 9. And we're left with on the top just 3, and on the bottom just x minus 2 for your final answer. Maybe try this one, flip the bottom fraction. So I've got 3 over 4x times 4x over 5. Look at that. 4x and 4x, they can cancel directly. That's kind of nice. And then I've got just 3 over 5. So again, complex fractions, not a big deal. Just remember they're another form of writing a division problem. Couple for you to try. Try it and simplify. X squared plus 5x over 2x squared minus 50. And the rest are there for you as well. So pause your video and then come back and see how you did. So take a look and see how you did. Pause your video if you need to check all your answers. Remember that you always, always, always must factor before you start canceling. Factoring is super important. All right, that's it for this lesson. Good luck with the homework and your mastery quiz.